Okay, this is section 9.1. We're going to talk about the Cartesian coordinate system, or sometimes referred to as the Cartesian plane. René Descartes was a famous French mathematician and basically discovered that we can do two axes here. An x-axis going across this way and a y-axis going vertically up and down like this. Okay? Now we can look at ordered pairs, and you'll list those ordered pairs as x and y. And simply it's a distance from out the x-axis and a distance up the y-axis. And you're going to do that from a point where those two things intersect. And this point right here, where those two intersect, is called the origin. And the value of x at that point is 0, and the value of y is 0. Okay? Now the order does make a difference, because what we're going to look at is we're going to look at the point 3, 4. The point 3, 4 means that I'm going to go over from that origin 3 units. 1, 2, 3, and then I'm going to go up 1, 2, 3, 4. And the intersection of those two lines is the point 3, 4. Now if I look at the point 4, 3, then I'm going to go out the x-axis 4 units. 1, 2, 3, 4, and up 1, 2, 3. And the intersection of those 2 points, those 2 lines rather, would be the point 4, 3. So you see that the order makes a difference. It's called an ordered pair. Okay? Alright, so let's see what we can do with this. Okay, so we've got our points 4, 3, and 3, 4. Let's suppose that I want to locate the point -4, 3. In that case, what I would come back, and this is the negative direction on the x-axis. This direction here is the negative. This is the positive. So -4 would be 1, 2, 3, 4 from here, and I want to go up 3. 1, 2, 3. This then would be the point -4, 3. If I want to locate the point -5, -7, I'm going to go, and I'll change that, 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5, 6, 7. This then would be the point -5, -7. One more point. Let's try 6, -4. Where's that point? Well, I'm going to go out the x-axis, 6 points, and down 4. So I'm going to come out 1, 2, 3, 4, 5, 6, and then down 4. 1, 2, 3, 4. And this is the point 6, -4. Okay? So now what I want you to see is that what I have in the first section, we've got quad meaning 4. Here's the first quadrant right here. This is the first quadrant. And the signs of the numbers are both positive. Positive 3, positive 4, positive 4, positive 3. Those were up in that first quadrant. This is the second quadrant. We do this counterclockwise. And I want to see that the signs are going to be negative x and positive y. The third quadrant is this one down here. 1, 2, 3. And both the signs are negative. This negative and negative. Both x and y are negative here. And in the fourth quadrant, the signs are positive, negative. Okay, so we've got 4 quadrants. We know the signs of those. We know how to locate the points. All right, let's see what we can do with this. Next on our list, we'll be looking at the equations of lines. Okay, equations of lines in the Cartesian plane are going to be of this form. And they will always be of 2 forms. Ax plus by equals c. And what that looks like would be 3x plus 2y equals 4. Or it could be x minus y equals 7. Or it could be negative 3x plus 2y equals 6. Okay, the bottom line is I've got a number and a variable y, and a constant. That's what I've got right here. A number and a variable, the number and a variable y, and a constant. The number here we understand always to be 1. In this case, the coefficient here would be negative 1. Okay, now let's just take a look at this one right here, just for a second. I want 2 numbers whose difference is 7. Well, you can look at that and you can see that 10 minus 7, or 10 minus 3, is equal to 7. You can see that 11 minus 4 equals 7. You could see that, I don't know, say negative 2 plus 9, that's 7 also. So the idea is there are a variety of numbers here that make this thing true. Okay, now let's go to our coordinate system over here. Alright, now what I want to look at are these values right here. Values of x and y can be listed as ordered pairs. So 10, negative 3 is one of our numbers. 11, negative 4 is one of our numbers. 2 and 9 would be a pair of numbers that works. 7 and 0 would be a pair that works. 0 and negative 7 is a pair that works. Remember that I've got 0 minus negative 7 does in fact equal 7. Alright, so let's plot these. Let's take it from the bottom here. 0, negative 7. 0 and down 1, 2, 3, 4, 5, 6, 7. So this is a point that satisfies this equation right here. 0, negative 7 works. 7, 0. Well, let's go out and do that one. 1, 2, 3, 4, 5, 6, 7. This point works because 7 minus 0 does equal 7. Now the truth of the matter is all I need are 2 points to make this line. I can draw the line through those 2 points right there. That in fact is the line of the equation. This line is x minus y equals 7. every pair of numbers on this line makes that line true. And every pair of numbers that makes it true is on that line. Let's see if I can find one. How about this point right here? This point right here looks like it ought to be about 6, -1. Now the question is, does 6 minus -1 equal 7? And the answer is yes, it does. How about this point right here? That looks like it's 2, 1, 2, 3, 4, 5. It looks like it ought to be about 2, -5. And you see 2 minus -5 does in fact equal 7. Now that's the concept of graphing linear equations. Now the next step is we're going to look at methods for plotting this equation not using this stuff right here with the points. There's a much easier way. This is a conception of what we're trying to see here. We're trying to visualize that this equation right here makes a line. This equation right here will make another line. Okay? And what I will tell you, and what you'll discover a little bit later on, I know that that line is going to look roughly like that. And you will too after the next session. That's all I have on this one. Stay tuned for the next one.